The first question that I have printed, this is going to be one of your data questions. So EOC question, but should be one of those ones that if you see it on the EOC, you should be really excited because there shouldn't be a reason why you should miss it. Is there a lag or are we good, guys? Like it looks like there might be a lag. Okay, so we're going to hit stat. We're going to hit edit. In your L1, you're going to put in 8, 11, 12, 10, all your data points. And then this is going to calculate because which statement is true if a 10th data point, 45, is added. There is a little lag. Okay, let's see if I can. Normally, do I get out and jump back in? What do? I can't even remember now. All right, I'll be right back. We're going to start with putting our data in our L1. Hopefully we got rid of our lag. And you're going to need to solve for the things that are discussed with first before you go add the new 10th data point. So it's going to ask us to add a data point, but we need the mean, the median. So the mean and the median are what all your answer choices are discussing. So those are the two things that we need. Mean, remember, is average. Median is the middle point. So we're going to hit stat, edit, put them in our calculator. We're going to write over to calc and then use one var stat. And then depending on which level of calculator you have, you want to get to calculate and then hit enter. So our mean is that X bar. So without that 10th data point, it's 8.22. Our median term is also the Q2. If you see it anywhere else written that way, it would be Q2 or median here, which would be 9. So median is 9. Now we're going to add that 10th data point. So we're going to hit stat. You're going to go to edit. You're going to go down to the bottom and add, in this case, 45. Something to note that 45 is very much an outlier because look at all your other numbers. Those 3 is our minimum and our max before we added that 45 was a 12. So that's a big jump. So just remember, outlier would be that term that's super large or super small relative to the rest of the data. So stat calc, one var stat, enter until you get some information on your home screen. And in this case, our mean is now 11.9, and our median is 9, and it stays exactly the same. So then we look at our answer choices. The mean and median both will increase. The median did not increase. It stayed the same. The mean will increase and the median will decrease. The median did not decrease. It stayed the same. The mean will increase and the median will remain the same. That one's looking really good. But just for conversation, the mean and median will both decrease. In this case, the mean did increase and the median remained the same. All right, another data style question. An administrator at a local hospital recorded the weights of newborn babies. Year 2016, the mean weight of babies was 7.3 pounds with a standard deviation of 0.8 pound. The year 2017, the mean weight of babies was 7.5 pounds and the standard deviation of 0.61 pounds. And I believe as I'm reading this one, we've already done this one. So I'm going to give you a second to look over your answer choices and see if you have a choice that you would rein in on. So would you want A, B, C? So would you think the weights of 2016 are more spread out around the mean than those of 2017? The weights of 2016 are spread out around the mean more or less, are less spread out around the mean than those of 2017. Or C, the weights of 2016 skew left while the weights of 2017 skew right. And then last but not least, there is no difference in the spread of weights from 16 to 17. So again, you're looking at your data, the information given at the top. So in 2016, the mean weight of babies is 7.3 and the standard deviation is 0.8. 2017, it's 7.5 and the standard deviation is 0.61. So if you had to pick an answer, what answer would you pick? Yep, it is A. They're more spread out because the standard deviation is larger. So this is where we talked about there would be a curve. Our mean would be in the middle, so in this case, it's 7.3, and then we would go one standard deviation in either direction. So 7.3 plus 0.8, oh my God, plus 0.8 would give us 8.1, and then 7.3 minus 0.8 would give us 6.5. So if it fell between 6.5 and 8.1, if that child's weight, then they are within one standard deviation of the mean. So it's going to spread out further because 7.5 for 2017 only went up 0.61. Ooh, and then 7.5 minus 0.61 is 6.89. That's tight. So they don't spread a lot more, but it does spread more. The next, like 2 standard deviations, would be a little bit wider. If they had an option saying that they were the same or similar, that would make us question answer A. But answer A from the answers that are offered is your best answer. All right, scatter plots and line of best fit. So line of best fit, where we did stat, right over to calc, linear regression. The data set is modeled with the linear best fit function. What correlation coefficient, and if you're using your TI-84, that's your R, when you cut your your 0 on, best represents the data set. So this is how tightly are these points grouped together in a linear function. So before we get into correlation coefficient, is this a positive or negative correlation? Good, negative, absolutely, because it's going down from left to right. So we're definitely going to do a negative. Would you call it strong or weak? Strong, good, because it's super tightly grouped, right? So super strong. And remember, strong is based off of 0 to 1 and also to -1. The -1 versus a +1 just means, is it going down or is it going up? So the closer it is to 1, the stronger it would be. Positive or negative doesn't matter, just as long as it's close to 1. If it's closer to 0, that's where you're going to get weak. Sometimes you can see like a moderate, moderate's the word I can think of right now, where it would be like at a 0.5, where it's dead in the center. So it's not really strong or weak. Very rarely, usually it's on either, good push to either side. So if it has a 0 correlation coefficient, does that mean it's strong or weak? Or no correlation? 0 would be weak, and it actually is like a no correlation. Because if there's a 0, that means it's not even remotely trying to group together linearly. So weak would be the best answer of the choice that I gave you probably right up front, but 0 would be a no. How about the negative 0.24? Strong or weak? Good. Definitely weak because it's closer to 0, right? And this would be a negative. So that, again, that is just saying that it's decreasing. It's going in the direction. So that negative sign is just the direction at which the points hit the graph, not if they're tightly squeezed together or not. So negative 0.96, is that strong or weak? Strong, right? Because it's close to that negative 1. Again, the negative does not mean it's further away from 1. It just means it's close to a negative 1. Negative 1 and positive 1 are game for strong on this guy. So this would be a strong negative correlation. So again, looking pretty good for this one. And then a negative 1 is going to be strong, weak, or perfect. It would be strong. It actually gets better than strong. It's perfect. That means the data is perfectly linear. Absolutely, like as if you were just plotting the dots on making a line before you drew the line through it. That would be that negative 1. It would just be a negative straight line versus if it was a positive 1, again, a perfect line, but it's just positive. So now that we've done all 4 of those, discussion-wise, which answer do you think best represents the graph above? A, B, C, or D? Good. C. D is too perfect. B is weak. And A would be none. So definitely your best choice answers are between C and D. Again, D is not good because D would look like this. Like absolutely. I mean, maybe there's extra points in there. Because just as a call out, as a line, if it happened to be a line, a line is a bunch of points squished together to make the line. So there could be as many or as few, but if it's perfectly, like in this case, a 1-to-1 slope, then that would have that negative 1 correlation coefficient. So just a couple like way throwbacks before we go too much further into the next, everyone's favorite, growth and decay. The function f of x equals 250 times 0.5x represents the amount of medicine in milligrams remaining in the body after x hours. What does 250 represent? The final amount of medicine, the initial amount of medicine, the amount of medicine after 250 hours, the amount of medicine decreasing by 250 each hour. What is 250 and that exponential function represent? Good. It's the initial amount. Perfect. Because remember, again, this is probably over talking, but it's A, our initial amount, 1 plus or minus the rate at which it changes as a decimal, and then raised to the time, or x, whichever variable you would like. Now remember, that rate, to change it to a decimal means divide by 100. If you want to change the decimal to speak to percent, multiply by 100. In this case, is this growth or decay? Good. Decay. Why is it decay? Less than 1. Yep, it is less than 1. Because we had 1 plus or minus whatever that percentage was, and we ended up with 0.5. How much is it decaying? How much less than $1 is it? So we want to always think about that this parentheses in relation, and I say $1 because it sounds weird, but most of you can think money. So if I think about it in $1, how much money did I lose from that dollar? And I did lose 50.5, right? So 50 cents, I lost it. That's why it's decay. And as a percentage, What is that 0.5 as a percentage, that negative 0.5 as a percentage? Yes, 50%. Now be careful. 50% is very different than 5%. 50% of $100 is $50. 5% of $100 is $5. Totally different shopping spree. Right? Totally different shopping spree. So you're always going to move your decimal 2 to the right if you want to change the percent, or if we're changing like 9, let's say 9.7%. And I'm giving you this one because people mess up because there's that 0.7. What would that be as a decimal? 9.7% as a decimal. For these type problems, like changing it to the decimal. Ooh, nope, can't do that. Can't round up. We're just moving that decimal. Yes, we're going to move it 2 to the left. And now our decimal would be 097. I'm going to do one more just to make sure we're seeing a pattern. So let's do 74.6%. And I'm picking ugly ones because I feel like you can do the pretty ones easier than the ugly ones. All right, so we're going to change that 74.6% to a decimal. What is 74.6% to a decimal that I could like plug into my equation? Good. 2 to the left. Exactly. 1, 2, so it's going to be 0.746. In growth and decay, you never use the decimal in the formula. You use you never use the percent in the formula. You use the decimal. And it's always 1 plus or minus whatever that percent is as a decimal. One more good throwback. All right. So looking at endpoints, midpoint, distance, and all that fun stuff. This question is not hard, but I know lots of students, as soon as you see diameter of a circle, your first thought is going to be like, we haven't done circles. Why would I have a question about circles? So here we are. Let's discuss it so we can say we've done it. In a circle, what is the diameter? Can you tell me what the diameter of a circle is? And the diameter is hard to explain. Can you tell me what a radius of a circle is? Okay, good. That's what I need to know. So circle, radius is from the center to the outside. So radius, center to outside of circle. All right, so that's a radius. A diameter is going to be 2 times your radius. Oops, I'm about to pick up the same color pen. That's not going to help us. So diameter is outside to center to other outside. So diameter, let's see if I can come up with a good mathy definition. The segment crossing through, I should have prepared this, sorry guys. The center that touches the outside of the circle. Also known as 2 times your radius. So it's double the length of the radius. So the diameter is 2 radii. And radii is your plural of radius. So just a fun circle lesson really quick. So of your parts of your circle. So radius is just from center to outside. Diameter is outside to outside, but has to pass through the center. Okay? So the diameter of a circle, so we're looking through this, we're looking at this line right here, has endpoints of 2, 7, and 4, -3. So 2, 7, 4, -3. What are the coordinates of the center of the circle? Hopefully when you see the word center and you're looking at the 2 coordinates given and you're thinking about what we've learned in our class, this is hopefully when you see center, you think midpoint, because that's the only thing in our class that we have learned that would even have sort of the same sort of meaning At this point, you have choices. Now, the formula for midpoint is x plus x divided by 2, y plus y divided by 2, because you need the x and the y, because it's going to be a coordinate when it's on the coordinate grid, when they're giving you coordinates, right? There's a couple ways you can do this. Mathematically, if it's calculator active, you could go plot those 2 points in Desmos or put them on a piece of graph paper and then count up and over and be able to graph it there. Or count, like if you're more of a visual learner, then you could actually plot the points and count out your midpoint. This is going to take me a minute, but I'm going to show you anyway. So we have 2, 7, and 4, -3. So if this is my origin, you can have as much paper as you possibly need on your EOC, okay? So ask for it. So 2, and then right, left, so over 2, 1, 2, 3, 4, 5, 6. Of course, I counted not enough, sorry. So 2, 7. So this is going to be our S point. And then we have 4, -3. So this is our origin. 1, 2, 3, 4. 1, 2, 3. So this is going to be our U. Now, you can count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has a height of 10 and a run of 2. So rise over run, so 10 over 2. That fraction can be reduced. What is that fraction reduced? 10 over 2 turns into what? In its most simplest form. Good. 5 over 1. So I'm going to start down here, and I'm going to go 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. So I just took that entire segment, and I cut it into 2 equal points, which means this is the center. Let's see if I can draw a straight line of our SU line. And now I can count. So 1, 2, 3, 1, 2. 3, 2. Is the midpoint of SU. So that's doing no algebra. That is simply just graphing and understanding slope. You want to simplify the slope as much as possible. Now be careful, because if it happened to be a 2 to 1, 2 to 1, 2 to 1, 2 to 1, and it's super far apart, you want to split it in half. We'll graph another one in a minute, and hopefully it'll do it, so I'll show you that. So our answer is going to be 3, 2. Algebraically, trust me when I tell you X, Y, X, Y, especially on EOC and test day, to mark those. You know it, but then as soon as you get caught up into doing questions and you're getting frustrated because you missed some and some aren't making sense to you, and you're sitting in a quiet room and you're not at your house, you're going to panic and mess up and make silly mistakes. Not I don't know math mistakes. So we need to minimize our silly mistakes. So you want to label X and Y, X and Y. And obviously it's on a computer, so write it down on your paper. Write the coordinate, label X, Y. Write the second coordinate, label X, Y. So we're going to do 2 plus 4, because it's X plus X divided by 2. And then we're going to do 7 plus a -3, or 7 minus 3, if that makes sense to you, divided by 2. But you want to remember the formula is addition. So 2 plus 4 is 6 divided by 2. So there's our 3. And then 7 plus a -3 means I had $7 and I spent 3. So I end up with 4 over 2, which is our 2. And that's the coordinate we also got when we were graphing. Now, that is the math teacher, two absolutely accurate math teacher way to do this. I know myself, and as long as I have 2 endpoints and I am solving for midpoint, my little rhyme to remember how to do this is stack them, add them, divide by 2. So stack them, add them, divide by 2. And that will answer almost every midpoint question you have. I'll show you some in a minute that it won't work for. But if the formula is more than you can manage in your brain and you don't want to necessarily graph them, stack them, add them, divide by 2. And that means I take my 2, 7, coordinate 1, coordinate 2. So I stack them, I add them, and I'm just going to come right over here. So 6, and then 7 plus a -3 is 4. Divide by 2, stack them, add them, divide by 2, 3, 2. So you have lots of options on how to do midpoint. Again, for future, in case you go back to campus, in case you go to another teacher, in case you Google and you go YouTube, this is the accurate formula. Graphing, stack them, add them, divide by 2 are just backup plans in case you forget formulas, because everybody has a day where we're thinking about squirrels. Okay? All right. What is the midpoint of the segment that has endpoints -5, -9, and 1, 6? Now, there's decimals. Don't panic, especially if you choose to graph. Just know and be careful and pay attention to your decimals. Think about it as money. You very rarely have to deal with decimals with more than 2 decimal places behind it. And you know what pennies are, you know what dimes are, you know what nickels are. So if you think about decimals as money, they're not quite as scary. I'm going to give you a second to solve this, and I'm going to go graph these points on this piece of graph paper I have and then come back. So you guys see whichever way you want to solve it. You can plug it in Desmos and go plot your points and then count on there. If you have graph paper, graph it, any of those things. But we're coming up with an answer. All right. I graphed X. So that's at -5, -9. And I graphed 1, 6. That's Y. Again, right, left first, then up or down. Right, left first, then up or down. This one is pretty spread out. So I'm not sure Desmos would be your best go on this guy, just because it might be hard to track it on your computers, especially since they're kind of tiny screen. But if you have graph paper, again, and if straight lines bother you, like being able to draw a straight line, obviously you don't have a ruler on your EOC, you have another sheet of paper. Use it to make a straight line. If you need to fold it in half to use it as your line, that would 100% work. But you do want to try to make straight lines. And this is just like solving for distance if you were to use Pythagorean theorem. So you're making that right triangle straight up and then straight over. So it's 15 high, 5 across. So 15 over 5. Now, we can count the slope and like reduce this slope, which would be beautiful, except it's going to go 3 times, which is a problem. So we want it only to go twice. So 15 divided by 15 divided by 5 is 3 over 1, right? So that means 3 over 1, 3 over 1. This would make it easier to graph our line straight. Uh-oh, I did something wrong. I didn't count. 1, 2, 3, 4, 5, 6. Yep, sure enough. 6. So scratch that 3 over 1 funny story, because that's not going to do anything for us. We could do 5 over 2. So up 5 over 2. Disregard my tiny purple dots. 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2, and then we're here. So that means our line, our correct line, and in this case the hypotenuse of our triangle if we were doing distance, but there's 3 chunks here. So it could, depending on how your brain works, you could go right here and count this guy in half. 1, 2, 3, 4, 5 by 2. Again, that's going to be 2.5 and over 1, and there's your midpoint. But if you also take 15, man, I'm making numbers up, guys. End of the week, I get really silly. And divide it by 2, that's at 7.5, and that's going to be 3. So if I count up 7.5, 1, 2, 3, 4, 5, 6, 7.5, count over 3, 1, 2, 3, I end up at our midpoint as well. And again, if this is blowing your mind, you don't have to be able to graph. I'm just giving you some options because there's like a 50 split when I'm in a classroom. that they prefer to graph or they prefer to do algebraic. But I'm trying to give you all the options and power you possibly can have. Did you guys come up with an answer? Did we get it right? Good. It was B. Yep. And again, if we wanted to do X, Y, and I'm probably over teaching, but -5 plus 1 divided by 2, -9 plus 6 divided by 2. It's addition, so it doesn't actually matter which one you grab first. I would say to other skills that you use in Math 1, I would pick, if I'm starting with point X, I would then use point Y for the X and Y coordinate. That was a hard conversation because I have so many X's and Y's. But if you start in this coordinate for X, start in this coordinate for Y, like we did here. So it's going to be 4 divided by 2. And that's a -4 because I owed you 5 and I paid you 1. -3 divided by 2. You're not going to see fractions on a graph unless it's slope. Because fractions, if I handed you a piece of graph paper and I said, go plot 3/4 over 0, or 3/4 0, you would go over 3, up 4, and then go nowhere and put a dot. Trust me. I've done this like to students all the time to prove a point. So remember, when you're talking about measurements, which is basically what a coordinate graph is, it's just measurements on a two-dimensional plane, you're going to have decimals. Slope is the only time you deal with fractions. So this -2, you don't want to leave that as a fraction. You want to turn it into that -1.5 as you had there. So again, probably over teaching, but giving you all the like oopses and things I've seen happen before in the front end so we don't make them on test day. So I gave you these guys on here, not thinking about grabbing my own graph paper for the other two. If you want to find midpoint, so again, this one's messy. 1, 2, it's up 3, 1, 2, 3, over 3. So that's a 3 over 3. If I half it, it's 1.5. 1.5. So if I go up 1.5 and then over 1.5, I'm sitting on my midpoint. If you are given a graph and no numbers, my humble opinion, I would count it. Only because I've watched more students, like unless you're very confident in grabbing this coordinate. So this is for -1. And this is 1, -4. Because if you mix up your X's and Y's, you have a problem. It's not going to work. Or if you miss a negative, or, just silly kind of mistakes that we all make. So if given a graph, I suggest counting it, or do it algebraically and then count it as well. Like go make sure it falls in the middle of the line. In Calculator Active, if you have Desmos, plot the 2 points. Make sure it looks like the one, like go put them in and make sure it looks like this line. Like it could be this line. Okay? Distance, just a quick, you guys said you were good on distance, but just a quick distance. Again, you're going to do the same thing. 1, 2, 3, 4, 5. And you want it to be a perfectly straight line because you are making a right triangle, because we are going to use Pythagorean theorem. Most of you chimed in on your Ed puzzle and said you like Pythagorean theorem better than the distance formula. So 1, 2, 3, 4, 5, 6, 7. So it's a rise of 5 and a run of 7. This is negative. It's a negative triangle. But as far as distance, that doesn't matter. This is a negative line. I'm sorry, not a negative triangle. Negative line. This is back, which we will do again soon. And you're wondering, what is your hypotenuse? So this is Pythagorean theorem this way. So we're going to do 5 squared plus 7 squared equals c squared. You can put x squared, whatever you want to put there. But remember the hypotenuse, which is the side, sorry, the other two are legs, directly across for your 90-degree angle. And on a coordinate plane, when it's a perfect line like this, your 90-degree angle is going to point towards your hypotenuse. Okay, 25 plus 49 equals c squared. 25 plus 49, 74, I believe, but I don't want to mess up. Yep, 74 equals c squared. What's the inverse of squaring something? What operation would you use to undo squaring something? Add, subtract, divide, square root, multiply. All right, good answer, but wrong. And I say it's good because it's the one we always pick. So again, we got to keep doing it, keep doing it, keep doing it. The more you miss, the smarter you're going to get in math. Nobody likes to hear that, but that's how it works. So if I divided this by 2, that wouldn't get the 2 out of the exponent spot. Square root, square root. Now, you should have a TI-84 on the day of your test. If you look, your square root button is right behind the x squared button. So your inverses are on the same button. So if I want to square 4, I push here and I get 16. If I want to find the square root of 16, then I use the same button after I hit second. And I just pick 16 as a number. So we're going to hit second square root. We're going to do 74. And it's going to be 8.6. The other call out is to make sure you pay attention to what the directions tell you as far as how many decimal places to round to. Very important. The days of rounding to a whole number are pretty much completely and utterly over. Never round to a whole number. Your math is just going to get, and I say harder, but more accurate the more advanced you get. So a whole number is not the same. If I tell you I'm going to pay you $8.60 an hour, or I'm going to pay you $9 an hour, it sounds like a small amount unless you work a 40-hour week, right? That's a lot. 40 cents times 40 is a big difference. Whether you're the person who got it or didn't, still the same conversation. So make sure you always read to see what they're going to tell you to round for too. But distance. So again, perfectly straight triangle. Use the corner of your paper on EOC day. Use your, and you can use it on your computer. Like just lift your paper up, because on a coordinate plane, it is as accurate as it will get as far as your right angles are concerned. I have 1 minute. This guy. I will make sure we do some of these at the on our next class, Monday. Endpoint is the one thing that students have problems, and there's usually always one on the EOC. It's one question. So don't panic, but if you could get it right, it's one you could have in your back pocket when you walk in the door. So remember, our formula is x plus x divided by 2 and y plus y divided by 2. To find the midpoint, you have to have 2 endpoints. So 6, 9 in our midpoint, the midpoint is 1, -6. This is our x, this is our y, this is our x, this is our y. This x is going to go in our formula because that's where we would normally do it. So 6, but we don't have the other endpoint. And our midpoint for the x value, and I just pushed x, sorry, is 1. Then for y, we're going to take our endpoint. It goes inside because our endpoints is what we compare to find our midpoint. And our midpoint is -6. And then we just solve this 2-step equation. So 2 times 1, we're going to multiply because that's division of 2. So 2 equals 6 plus x. How would I move that 6 to the other side? Yes. So we're going to x equals a -4. Now we go over here to our y. Again, we need to get 2 out of the basement or the denominator. So we're going to multiply because that's the inverse of division. So it's going to be -12 equals 9 plus y. We want y by itself. So we're going to subtract 9. And sorry, guys, I'm going kind of fast because I want to be respectful of your time. So this midpoint should be -4, -21. The other way you can do this, and then I promise I'm done, is if you go and make sure you pay attention to the fact that it says endpoint and midpoint. These are bigger numbers, so it might take me some more space. So there's my origin. I'm going to go 6, 9, 1, 2, 3, 4, 5, 6, 1, 2, 3. 6, 9. So this is our endpoint. And then our midpoint is 1, 1, 2, 3, 4, 5, -6. That means half of my line is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 high, and 1, 2, 3, 4, 5 across. I hope I said 15 is right. 15. endpoint, midpoint. If I go the other direction, the same amount, so 15, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm already on my other graph. And then over 5, 1, 2, 3, 4, 5. This should be our other endpoint, which we got was a -4, -21. From my origin, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm coming back to the screen. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. -4, 21. A little tedious, but if you don't remember the formula, again, you can graph it. See if I can back out so you can see the whole thing. Hopefully you understand what I just did because I couldn't get it all on the screen at once. So this was the midpoint given. Endpoint at the top was given. And then we just duplicated it to continue our line in the other direction in the picture.